right, in this video, we're looking at Chapter 6, Section 4, so St. James heading, Chapter 6, Section 4, and then underneath that you write symmetry. Okay, this I know you've done since like second grade. Um, we're just going to use it a little differently, especially when it comes to finding your uh, geometry and trig formulas. So that's coming up a little bit later in the year. But anyway, this is just a refresher. So a figure has line symmetry if it can be folded over a line so that one half of the figure matches the other half. Okay, this fold line is called line of symmetry. And you're going to see it's a dotted line. Okay, and I have some examples below. So some figures have more than one line of symmetry. So here's some examples. You have the heart is just, here's your line of symmetry, and there's one of them, just one line of symmetry. And you can, if you hide, take your hand and cover one of the sides of the heart and you fold it over, it looks exactly as the other side. This triangle has three lines of symmetry. So one here, and one here. And each of them, as you fold it, will match the other side. That's when you know it's a line of symmetry. Square has four lines of symmetry. One here and one here, and then on the diagonals as well. Okay, your circles, if it's a perfect circle, not something that's oblong, like an oval table, not oval, but a perfect circle will have actually an infinite number of symmetry lines. Infinite means every single line, I could draw lines in between here and lines in between here and lines in between here. And I could just keep adding lines and adding lines, an infinite number of fold lines. And if you fold over the circle on itself like that, it would match. Okay, here's some more examples of line symmetries. Okay, not hard, it's just a matter of paying attention to all the different folds. Okay, so the other thing to pay attention to that you might not have had in other classes is rotational symmetry. Rotational symmetry actually is really important. If you go on those merry-go-rounds or any of those, the whip and things of different rides in, you know, parks and things like that, you're going to find that the rotational symmetry is really important. If the rotational symmetry is off, that's when people usually start to feel dizzy or uncomfortable because their center of balance is then off. But if your rotational symmetry is correct, and if the engineer did their job correctly, then actually you're not going to feel very dizzy at all if it's done correctly. But then again, if their goal is to make you dizzy, and that's part of the ride, then they might purposely make it so that the rotational symmetry is off. Okay, so a figure has rotational symmetry if it can be rotated or turned less than 360 degrees about its center so that the figure looks exactly as it does in its original position. So here I have two shapes, rectangle and just an arrow. In my rectangle, I could actually rotate this. So here, let's, I'm gonna color that dot. The dot is not gonna move with it, but it makes me feel better. Okay, you can see that's where the dot started. If I rotate it just 90 degrees to here, it does not look the way it did when it started. So its rotational symmetry is not 90 degrees. But if I rotate it again to 180, this is 180 degrees, then yes, it has rotational symmetry. It's 180 degrees because now it looks exactly as it did when it began. Okay, its rotational symmetry is 180 degrees. Okay, it is 180 degrees. Anything less than 360. So here's my shape again, and I rotate it more. Okay, and then I bring it back to its beginning. That would be 360 degrees. It went all the way around. So it has to be less than 360 degrees. Let's see what happens with this arrow. Okay, here's my arrow, and I'm going to rotate it. All right, I rotate it 90 degrees. It does not look like it did when we began. So no, not yet. It doesn't have rotational symmetry. It's not 90 degrees, so I'll just cancel things out. So no, it doesn't have 90 degrees. That's going to get in the way. Okay, nope. All right, and then I rotate it 180 degrees. Nope, that does not look the way it did when we started. Now the arrow is pointing down. So nope, it does not have, it's not 180. Okay, and then here we rotated another 90 degrees. Okay, so 270. So nope, not 270. Nope. Okay, and we rotated all the way back to 360. Okay, so yes, now it does, but but the rule is for it to be rotationally symmetric, it has to be less than 360 degrees. So no, it does not have, no, just say no rotational symmetry. Okay, right, no rotational symmetry. Okay, so the arrow does not, no. Okay, no, it does not. All right, let's try another one. Okay, let's try this one here. This is a polygon. Okay, so first, does it have line of symmetry? Does it have line of symmetry? So line symmetry. Okay, well, if I fold it here, does that work? No, because when I fold it on itself, it actually, the points don't match up. If I would picture this, I could picture it, it actually would kind of look like that. If I folded it on itself, that's what it would look like. So no, it wouldn't match up. So nope, doesn't match that way. Okay. So if I did line of symmetry this way, well then it would kind of fold on itself like that. This would be the new, so no line of symmetry. No line of symmetry. Okay, but does it have rotational symmetry? This is where you have to be able to picture the shapes in your head, because now in this case I can't rotate it. I don't think. I'm going to try. Let's see if I can rotate it. Okay, let's see if I can rotate this. Okay, so here I go. Okay, cool. So here's 90 degrees. This is starting to begin out. This is 90 degrees. It's not symmetric. That's not how it started, but that is. So yes, it has rotational symmetry, and it's 180 degrees. Because when I rotate it 180 degrees, that's exactly how it looked when we began. So yes, it has rotational symmetry, but does not have line of symmetry. Okay? All right. No problem for next class because, again, we're going to be doing a lot of them in your workbook, so no problem for next class. No problem for next class. Just want to write that down so you don't forget. No problem for next class. Okay? All right. See you next class.